Okay, calculating energy of a photon. This is that second formula that we learned. The first one was constant equals wavelength times frequency. So that's speed of light lambda was wavelength. And F is frequency. If you don't remember how to do that, check out the other video. It's on the channel. When I get smarter and I figure out how to put links in descriptions or like little pop-ups in the video, we'll do that. But until then, just find the other video. Now we start all over. Okay, now the calculating energy of a photon would be energy, capital E, of a photon is equal to H times F. Now, just like in our other formula, F is still frequency. Make sure you know the vocabulary word. It'll be on your test. Frequency. E is energy. That one I know blows your mind. Energy. And H, this is the new one. Just like speed of light, this one's a constant, but rather than speed of light, this one is Planck's constant. Constant. There we go. Named after Max Planck. You can do some research on him if you really care. He was one of the guys that helped to develop the quantum model of an atom. Pretty smart, pretty interesting guy. Won a Nobel Prize. Anyway, his number, this is the one I told you don't have to memorize. I'll give you on your test, 6.6. Whoops, totally messed that up. Try again. There we go. 6.62 6 e to the negative 34 joules times seconds. Actually, good review. Our unit for energy is the joule, capital J, and frequency is hertz, which is technically 1 over 1 second. This becomes important in a minute when we do some examples. But for now, just know it. Okay, now those of you that are more visual than auditory, here is what I just told you about the units, but in words form. So, yeah, take a second, write these down. Energy is in joules. Your symbol is a capital J. Planck's constant, that super big number, that's joules in seconds, and frequency is 1 over 1 second, or the symbol is hertz, Hz. Let's take a second, write those down. Our first practice problem, what is the energy of a particle with a frequency of 3.31, oops, let's change that to a 3 so our math is easy, 3.13 e to the 9th hertz. Okay, well, let's write that out. First we write our equation. E equals H times F. Now fill in what we know. We're looking for the energy. What is the energy? So energy stays E equals H constant. H is Planck's constant, and since it's constant, it never changes. We really know what it is. 6.626 e to the negative 34 joules second times, we're multiplying, 3.313 e to the 9th. Then we're going to write it very small because I ran out of space. Hertz. Nailed it. Okay, take a second, try to solve it. A mild editing error, so we're just going to start again. We ended up with energy. No, not erase. Energy equals 6.626 e to the negative 34 times 3.313 e to to the positive 9. If you plug that in the calculator, you should have ended up with energy equals, get it together, bro. Energy equals 1.915 e to the negative 24. And then energy is in joules. That's what we should have gotten. We'll do one more practice problem. This time we're going to solve for frequency based on energy. There we go. Okay, so we're going to say we have an energy of, let's pick a good number, 4.8 e to the negative 34. Whoops, not negative 34. That's Planck's constant. That'd make this way too easy. E to the negative, let's go with a big number, negative 6 joules. It's going to be a huge amount of energy. So write your formula. Energy equals H times F, 4.8 e to the negative 6 joules equals Planck's constant, 6.626 e to the negative 34 joules in seconds times F. Now, divide the whole thing by 6.626 e to the negative 34 joules in seconds. This whole thing cancels out with this whole thing. You end up with just F, and then divided by 6.626 e to the negative 34 joules per second. Okay, joules cancel. Totally gonna have to bust out my calculator for this. Totally did not just hit pause so I could hit up that calculator, but through just my own pure genius, we now know that since we're only left with F, that its frequency is going to equal 7.2 e to the 27th hertz. That is a stupid amount of energy, stupidly big, but obviously this isn't real. This is just demonstrative of how to use this formula. If you have questions, make sure you're coming to tutoring, leave it in the comments, whatever, it doesn't matter. Just get a hold of me somehow.